Hello, everybody. Welcome to the course on digital signal processing. So, my name is Shom Chakraborty, and I am an assistant professor in the Department of Electronics and Communication Engineering in UEM Kolkata. I welcome you all to this course on digital signal processing. And as you know, this is obviously a very important course, especially if you consider the prospects of digital signal processing from an electronics point of view. So, a person who is in the ECE field, electronics and communication engineering, must have a good idea or must have a basic idea about digital signal processing. So that is why this course is very important to understand, right? So without wasting any time, so let us directly go into the course details. So first, in this part, we'll get introduced to the course. What is the course all about? What does it deal with? What are the prerequisites that are required in order to understand this course? All these things will be covered in this introductory lecture. Okay. Okay, so this is a beautiful campus, as you can see. So, okay. The first thing that you all should know that why should you take up this course? What is the motivation or what is the reason behind which you should actually take up this course? Now, the first motivation that I'll tell you is that now this course has got wide applications in various fields, in different fields like telecommunication, consumer electronics, image processing. So everywhere in this field, telecommunication, you need digital signal processing. In consumer electronics, even in TVs also, you need signal processing. In image processing also, either you can in order to enhance the quality of the image, you need digital signal processing. Also, in case of medicines, in order to have an ECG or an EEG, you need digital signal processing in order to extract the information from a signal. So this is a very important aspect of this. Now, digital signal processing has several advantages over analog signal processing. Now, previously, there was something which is called analog signal processing. Now, analog signal processing also, it mainly processes analog signals, but we know that there are a lot of advantages of digital signals over analog signals, and as a result of that, we have made a huge switch from analog to digital, right? So since we have directly switched from analog, so since we have switched from analog signals to digital signals because of their advantages, so the processing, so if the processing can also be done in the digital domain, then also it gives a lot of advantage. Okay, and digital signal processing has got its own advantages compared to analog signal processing. Now, one of the basic advantages is that of simple circuit design. Now, digital signal processing, especially if it scales down to the binary signals, if it is processing the binary signals, then you can understand that binary signal only decides between a 0 and a 1. Okay, so binary signal has to decide between whether the signal is a 0 or whether it's a 1, and hence in order to do that, the circuit becomes very simple actually, right? It's very simple circuit. Okay, the next one is that it's quite cheap. The digital signal processing is quite cheaper due to the you can say the enhancement or the development in the manufacturing technology. So with increased enhancement in the fabrication technology, especially in the silicon industry, with days with more and more advancements, we are being able to generate smaller and smaller devices. Okay, And because of those enhancements, we are able to make complex circuits at a very cheap rate. That is why it's quite cheaper, and the most of the processors that you have, the microprocessor, it is actually a digital signal processor. The laptop, the computer from where I'm actually giving this lecture, it also has a digital signal processor inside. So whatever signals are generated inside, they are all digital signals. The third one is ease of data storage. Data can be very easily stored on a digital signal processor. It can be very easily put into basically digital data can be very easily stored. So after the data is processed, it can be stored easily on CDs or floppies and all those places. Okay. And the most important advantage is the noise immunity. So no matter if the signal is affected by noise, as you know, it's an unwanted signal that interferes with an input signal. So if an unwanted signal interferes with an input signal, the quality of the signal gets degraded. Okay. Now, since digital signals are they are quite noise immune, that is, they are not affected much by the presence of noise. So we can obviously say that this is one of the basic advantages of digital signal processing over analog signal processing. Okay. And the last one, the most important one, it serves as a foundation for the ECE students to learn about communication systems. So basically, in order to understand better about communication systems, the ECE students, the electronics engineering students, must have an idea about the processing of signals. Okay. So this course sets up their foundation and the motivation to take up courses like analog communication or digital communication, because they will need the concepts of DSP or digital signal processing in those subjects. Now, some of the prerequisites that you can check. So it's understanding of complex number algebra, trigonometry, linear algebra, differential calculus, convergence of series. That's the most important thing, means whether a series is convergent or not, that's required, and some basic knowledge of signals and systems. So the learner must have a basic knowledge of all these topics, especially basic idea about the course on signals and systems. Now, what are the objectives of the course? Let us check. First is that to understand the basics of DSP or digital signal processing. So we want to get a basics of that, and to understand about the discrete time signals and the discrete time LTI systems. So LTI full form is linear time invariant systems. We'll go into that as we move ahead in the course, right? So we need to understand about discrete time signals. We will discuss about that. Third is to understand about the different transformation techniques for signal processing. So we are also interested to understand about the different techniques which are useful for signal processing, especially the techniques like Fourier transform, Z transform, which are used to convert a signal in the time domain into the frequency domain. And by doing so, the signal processing becomes quite easier. And there are a lot of advantages in converting a signal from the time domain to the frequency domain. Okay. The fourth objective, to understand about the filter design. So the fourth objective is also very interesting, that we also are interested in designing digital filters. Okay. So we'll discuss more about filters as we go about in the course. To have a basic understanding of digital signal processors. So we'll also have a basic idea about them, that what are these digital signal processors and how do they actually process these signals. Now, what are the topics that we will be covering in the course? Just in a nutshell. So we would be discussing about discrete time signals, the different types of discrete time signals. Then we would be discussing about systems. the different types of LTI systems. So here we are mainly interested about LTI systems, that is linear time invariant systems. System is nothing but it's a device, it's a physical device which operates on any signal to generate an output. Okay. Third is we'll understand about Z transform, which is a very basic transformation technique. We would understand about discrete Fourier transform. We would understand about fast Fourier transform. We would understand about filter design also. Okay. And the last, we will all deal with the digital signal processor, a basic digital signal processor, and how does it processes a signal. Okay, so this was a basic introduction to the course. For more queries, you can mail me in my mail ID if you have any more queries related to the course. So thank you for listening to my lecture with patience. Thank you so much.